We're going to be graphing linear inequalities today. But first what I want to do is go back to graphing lines, which are linear equations, and just remind what's going on here. So if we had a graph y equals 2x plus 1, when we graph that, we'd start at 1 on the y-intercept, then we do a slope of 2, so up 2 over 1. And we end up with a couple points, and then we can graph our line. And this line is made up of many, many points, an infinite number of points that make this true. So we can think of a few here, like if we put in the point 0, 1, x is 0 and y is 1, we could plug that in here, x is 0 and y is 1, and it would make it true. We could plug in the point -1, -1. And we could put that in here to make it true. So there's an infinite number of points along here that make this equation true. So when we're graphing linear inequalities, we are trying to find all points x and y that we can plug into the inequality, not an equation with an equal sign, but an inequality, and make it true. We'll do this by graphing. So we'll graph a line very similar to how we graph this, and then highlight or shade the points that work. So depending on the inequality sign used, the actual line may or may not be part of the solution, and we'll mention that as we go along. So to graph linear inequalities, the first thing you want to do is put it in slope-intercept form. So y equals mx plus b form. And when we do that, realize we won't have an equal sign here. We'll have something like a greater than, a less than, greater than or equal to, or less than or equal to. We'll be using one of those signs. Also remember, when solving inequalities, if you multiply or divide both sides of an inequality by a negative, you have to change the direction of the sign. So please remember that rule for inequalities. Number 2, once we have it in slope-intercept form, we're going to graph the line. Just like we did up here, we use our y-intercept and our slope. And then with graphing our line, we need to recognize there's something different that happens here. If we have a less than or equal to or greater than or equal to, which has the little line underneath, we're going to put a solid line, just like we do here. And the reason we put a solid line is because that means the points on the line are included in the solution. We use a dashed line if the inequality is just less than or just greater than. It doesn't have the or equal to, and this means that the points on the line are not part of the solution. So put it in slope-intercept form. You draw the line. Sometimes it's solid, sometimes it's dashed, and then you're going to shade. And what we do is we shade below the line if we have a less than or equal to. We shade above the line if we have a greater than or equal to. Now I do have a little something extra over here. If it's less than or equal to, and it's a vertical line, we shade to the left because of those things less than the line, or greater than or equal to, we shade to the right. And so we're going to remember these things as we work through our several examples. So here's the things I just mentioned here at the top, and so we'll use those to graph these. We have the first one, graph the following inequalities. Well, we want to put this in slope-intercept form, so we have to solve for y. So the first thing we'll do, we'll subtract 2x from both sides. I didn't leave myself a lot of room here, so we'll come up here then. Subtracting 2x from this side leaves us with 3y is less than negative 2x minus 9. And now we're going to divide each term, really both sides, but we're dividing each term by 3. We did not divide by a negative, so we don't have to change this sign. And once we do that, we get y is less than negative 2/3 x, and this is negative 3, so minus 3. And so we're going to graph this. We start at our y-intercept of negative 3. We use our slope of negative 2/3. Now, remember this negative 2/3 we can think of as negative 2 over 3 or 2 over negative 3, either way. So using this one, we can think, well, we would go down 2 and right 3. We can put a point, and we can do that a couple times. Or this one, this is a rise over run, so a positive 2 and a left 3. And then we want to graph this line. Now, looking at this sign, we know we want it to be a dashed line because this is not an or equal to, it's just less than. So we're going to make a dashed line through here. Put our arrows on here. So there's our dashed line. And also this inequality sign. This inequality sign tells us that we want to shade below the line. And so what this graph shows us is all these points in the shaded area will make this original inequality true. So if I pick the point right here, this is the point 0, -5, 0, -6. I can put that in here. 0 for x, -6 here, which would be -18 is less than -9, and that is true. So anything in the shaded region will work. The points along the line on this dashed line do not work. So if we picked this point right here, 0, -3, we would have 0, a -3 here, so 3 times -3, and we would have -9 is less than -9, which is not a true statement. And that's why we have a dashed line. Over to this next example. This is already in slope-intercept form, so we don't have to do anything with that. So we can graph this. So down 7, our y-intercept is 7. Our slope is 4, or 4 over 1, which means you go up 4 and right 1. And I'll do that a couple times. Up 4, right 1. Now when we graph our line, this is a greater than or equal to. So since it has the or equal to, we use a solid line because those points are part of our solution. And then it's a greater than or equal to, so we want to shade above. So above, what you can think is, sometimes you even pick the y-axis. These are the points above it, so everything on this side or above this line. It's a steep line, but these are still the points above the line, which again, the shaded region represents the points that work, and the points on here work this time because we have the or equal to. Next couple examples are similar. So here we would solve for y, so we can add 3x to both sides. And we also want to get rid of this 15, so I'll subtract 15 at the same time. And so that gives us a -5y is greater than or equal to 3x minus 15. And then we're going to divide both sides by -5. And we are dividing by a negative, so we do need to switch the direction of the sign. So this is going to be y is less than or equal to -3/5 x. And a negative divided by a negative is positive, so +3. And so we'll start here at 3 as our y-intercept. We'll go, let's use our negative in the numerator, so we'll go down 3 and right 5. We also could go up 3 and left 1, 2, 3, 4, 5. This is going to be a solid line because we're using the or equal to. And it's a less than or equal to. So we switch the direction of the sign, so we need to make sure we look at this equation to figure out where we're shading. It's a less than, so we're going to shade below here. And again, what this means is everything in the shaded region and on the line, because it's a solid line, will make this inequality true. Our last one is pretty much in slope-intercept form. It's got the y on the right side, which if it was an equal sign, we would be okay with that, but it's not. So let's rewrite this so the y is on the left side. So we want to keep this towards the y, so this is going to actually be a y is greater than, and we put the x term first, so -3x plus 7, which means our y-intercept is at +7. Our slope is -3, which we can think of as -3 over 1. So our rise is -3, which means a down 3. So we're going to go down 3 and right 1. Down 3, right 1. And we'll keep doing that to maintain our accuracy. We're going to use a dashed line because it's just a greater than. It doesn't have the less, the or equal to there. So dashed line, and this one was a greater than sign, so we want to shade above our line. So everything in this part, and so all the points up here would make this original inequality true, but not the points on our dashed line because it was just a greater than, not greater than or equal to. And so this is very similar to graphing lines. You just have to remember or determine if you're using a dashed line or a solid line, and then where to shade. And that is graphing inequalities.